Welcome to the Deep Dive. Today, we're looking at Proxima Centauri, our closest star neighbor. Sounds like it's just down the cosmic street, right? But, well, this deep dive is going to unpack the, frankly, terrifying realities of trying to actually get there. We're talking huge challenges, but also maybe some incredible opportunities for humanity.
That's right. Our mission today is really to get our heads around why this supposedly close star is actually separated by a gulf so vast it pushes everything we know, physics, economics, even our own psychology. We need to explore the sheer scale of it and, the dangers of space itself.
Right, yeah, let's dig into that. Proxima Centauri is 4.2 light years away. Just think about that light, the actual fastest thing there is. It takes more than 4 years to make that trip.
And visualizing that distance, it's tough. One way to think about it is like if Earth was a marble sitting here in New York City, Proxima Centauri wouldn't be orbiting nearby. It'd be another marble, maybe somewhere out in the middle of the Pacific Ocean.
What?
And just emptiness in between, pure vacuum. That gap isn't just distance. It's a barrier challenging, well, everything. Engineering, biology, you name it.
And our fastest spaceship, New Horizons.
Yeah.
Which is like screaming fast at 36,000 miles an hour. It would still take something like 78,000 years to get there.
78,000?
That time frame. It covers all of human history, several times over?
Pretty much. It's almost impossible to comprehend, really.
So, okay, the sheer power needed just to start the journey is one thing. But what about actually being out there? You mentioned space isn't empty.
Exactly. It's not empty at all. It's more like a gauntlet. You've got radiation, for starters. We're talking high-energy cosmic rays from deep space constantly smashing into things, potentially shredding DNA.
Right.
And then you have solar storms from Proxima Centauri itself once you get closer. Cooking anything unprotected, shielding from all that. It's heavy, really heavy, adds massive weight.
And I read about dust too, tiny little specks.
Oh yeah, dust is a huge problem. If you're moving at, say, a theoretical 10% of light speed, which is incredibly fast, mind you, hitting even a microscopic grain of dust is like getting hit by, well, a hand grenade.
A hand grenade. Seriously.
In terms of kinetic energy, yes, it could punch right through steel. So it's this constant danger, like cosmic bullets everywhere.
Okay, so distance, radiation, dust. Why not just moving the ship? Propulsion.
Well, that's the fundamental killer, maybe. Chemical rockets like we use now, forget it. You'd need fuel tanks bigger than planets. Even our fastest probe right now, the Parker Solar Probe, which gets up to something like 430,000 miles per hour.
Which sounds incredibly fast.
It is, but it still need over 6,000 years for this trip.
6,000 years. Still way too long.
And the energy. Just to get 1 ton of mass up to that 10% light speed we mentioned, you're looking at the total energy the entire United States uses for maybe 2,000 years, just for 1 ton.
That's almost unbelievable. The scale is just staggering.
It really is.
Okay, so the engineering is mind-boggling. But what about the people, the human side of this?
Right. The human cost. There's Einstein's time dilation. It's a real effect of relativity. If you travel close to light speed, time literally slows down for you relative to someone stationary.
So the crew on a 4.5-year trip, from Earth's perspective,
might only experience, say, 8 months subjectively. But here's the kicker. When they return, Earth would have aged much faster, maybe 5 times faster in this example. Everyone they knew could be gone. They'd be like temporal exiles, strangers in their own time.
Wow, that's a heavy thought. Temporal exiles.
And then there's the destination itself, Proxima B. If we even manage to get there, it's probably not paradise. It's likely tidally locked to its star, meaning one side always faces the star. Imagine eternal scorching daytime, hot enough to melt lead.
And the other side.
Eternal night, freezing cold near absolute zero where atoms barely move. Any chance for liquid water, maybe life, would be in this narrow strip, this twilight zone between the two extremes.
A twilight zone.
Yeah, and constantly battered by hurricane-level winds whipping around the planet and deadly flares erupting from the star, bathing the surface in radiation.
Okay, that sounds less like a new Earth and more like, well, a nightmare. Is it even remotely habitable for humans?
That is a huge question. Scientifically, it looks incredibly challenging, maybe impossible for surface colonization as we imagine it.
So with all of this, the distance, the dangers, the time weirdness, the potentially hellish destination, why? Why even think about doing this?
That's the core question, isn't it? And I think you have to look at the really big picture. Species survival. Earth, our only home right now, faces existential threats. Asteroids, supervolcanoes, climate change, you name it. Having colonies on other star systems, Well, it's the ultimate insurance policy for humanity, ensuring we don't put all our eggs in one basket.
The ultimate backup plan.
Uh,
But the cost, you mentioned the energy, the resources must be astronomical. Trillions, quadrillions.
Oh, easily. It would dwarf the GDP of nations. But then you have to ask, what's the price tag on ensuring humanity continues to exist? It reframes the question of cost versus value, doesn't it?
It does. So it's not just about survival, but maybe growth, evolution.
Exactly. The sheer act of trying to develop the technologies needed for interstellar travel, the propulsion, the life support, the AI, the energy generation, that effort alone would revolutionize life back here on Earth. Huge breakthroughs in medicine, materials, computing. It forces us to advance. It pushes our evolution as a species, forces cooperation, forces us to think long-term, beyond our immediate squabbles.
Like one of our sources said, the impossible has a curious habit of becoming inevitable when humans decide to make it so.
Precisely. It's about setting that audacious goal.
So we've covered some serious ground today. Crushing distances, cosmic dangers, physics pushed to the brink, Proxima Centauri. It feels less like just a star now and more like a challenge reflecting our own potential.
Yeah, it really forces us to look beyond ourselves, doesn't it? To cooperate, to evolve our thinking. This deep dive, I think, really highlights how tackling the biggest challenges out there might actually unlock our greatest opportunities right here.
A lot to think about. What's the one thing that really sticks with you from all this today? Something for all of you listening to ponder as you maybe look up at the night sky tonight.